Good evening, everybody. In the next half hour or so, I'm going to take you through astrophotography, but astrophotography without using a telescope. In other words, I'll say a little bit about telescopes, but most of what I'm showing here are pictures of the night sky that you can take using a camera and, as indicated here, without a whole load of ridiculously expensive equipment. I'm sort of working on the assumption that maybe you've already got a camera. Please come in, take a seat. Maybe you've already got a camera, and maybe you've never thought of turning the camera onto the night sky. So, what I'm going to be talking about is how you can start simple. In other words, if you've got a camera, all you would need is a tripod to start taking pictures of the night sky. Do you need a telescope? Well, you don't, but I'll just touch on the idea of doing astrophotography with a telescope. Maybe you've got one, maybe you're thinking of buying one. I'll happily answer questions at the end about buying telescopes if any of you are interested. But I'll be mainly talking about using cameras and no telescope, effectively just using a camera. And then I'll show some of my images to prove it can be done. And then I'll say a little bit about the benefit of getting away from light pollution. The idea of taking pictures from the middle of Liverpool with lots of street lights everywhere, well, that makes it difficult to see the night sky. But if you can get away from the light pollution, as we call it, the street lights, and one of the best ways of doing that is to go somewhere very remote. I've been lucky enough to go on some holidays in Africa where you can get hundreds of miles away from the nearest street light, and there you have beautiful dark skies. So let's start simple. Just a camera and a tripod. Take a camera, put it on a tripod, point it at the sky. It helps if you know how to use the camera. In other words, you might, if you haven't used the camera recently, you might have to go back to the manual and remind yourself how it is that you take a nice long exposure. You don't want to take a short exposure. You want to point it at the sky and expose for, ideally, many minutes. And here, this is something like a 5-minute exposure. And perhaps you can see that the stars have moved slightly. Perhaps you can see that the stars towards the edge have quite definitely moved, and perhaps you can tell that the center of rotation is that point there. That's the North Pole star, Polaris, and all the stars appear to have moved around that. That's because the Earth's axis is pointing at that star, and so as the Earth rotates, the stars appear to move. And if you take a very long exposure, not just a few minutes, but perhaps a few hours, then you can see the stars move quite a substantial amount. And you can take a picture like this. You don't have to expose for 6 hours. You can take a short exposure and then another short exposure, then another one, then another one. And by the magic of computer software, which is freely available, you can stitch them all together to get this picture of what the sky would look like over 6 hours. And also, you can stitch them together into a movie, so you get this impression of the stars wheeling around the North Pole being about here. So it looks a little bit like daylight because the sky is blue, but that's only because there was a full moon this particular night, and the full moon is illuminating the grass and making the sky rather blue. But this is the sort of picture you can take. Again, it helps to get away from street lights, but there's no reason why you can't take these sorts of pictures from your back garden. Every so often we have a visitor to the solar system. A comet comes through. A comet, a large icy snowball, if you like, or a dirty snowball. Sometimes they have glorious tails. This particular comet started to evaporate but didn't produce a huge tail. But here, again, a picture of the comet taken just with the camera on a tripod, effectively nothing else. In this case, I exposed for about 30 seconds to take this particular picture. If you're very lucky, you can get to see the northern lights. Maybe some of you did recently when the sun was very active. Some particles from the sun hit the Earth's atmosphere and can cause this glowing green, sometimes red light. So this wasn't taken from the United Kingdom. I went to Iceland here to get these pictures. And if ever you're taking a holiday in Scandinavia or Iceland or anywhere well north of England, close to the Arctic Circle, you might be lucky enough to see the northern lights. Every once in a while it might be possible to see them from the UK, but the displays are definitely better if you can get to Scandinavia or Iceland. And again, being in the right place at the right time, if you're ever in the right place at the right time to catch a solar eclipse, it is an absolutely magnificent sight. But you can't simply stay in England and say, I'm going to wait until the moon covers the sun to get this glorious picture, because it doesn't happen very often. Unfortunately, if you do want to get that sort of picture, you have to look up on a web page, where's the next eclipse taking place, and you have to decide, am I going to take a holiday and visit this particular country in order to be at the right place at the right time to catch a picture like that. So you can't have those sorts of pictures to order, if you like. So do you need a telescope? Well, it would be nice to have one of those. Perhaps you recognize this particular one. It's going to come to the end of its life eventually, so watch eBay just in case. You might be able to put in a low bid, and if nobody else wants it, you might be able to buy the Hubble Space Telescope. But of course, it's probably going to cost a few $1 billion, and that's the only way of getting absolutely incredible pictures like this picture of a galaxy, or the picture there of some nebula where stars are being born. But it is possible to say, well, I can't afford the Hubble Space Telescope. Could I buy an amateur telescope? Well, certainly possible. Unfortunately, you'll have to spend hundreds of pounds, or if your pockets are really deep, thousands of pounds, in order to get one of these telescopes. If any of you are thinking about maybe, perhaps in the future, buying a telescope, let me know afterwards and I can give you some advice, some guidance as to how you go about thinking about that. Some telescopes use lenses to focus the light. Some telescopes use mirrors to focus the light. We don't have to worry about the difference here. It's simply the case that if you buy an amateur telescope, you will be able to get superb views of, for instance, our nearest neighbor here. Here's a picture of the moon, and you can see it's half moon. The sun is illuminating one half of the moon, and you see on this edge you get a lot of beautiful detail of craters and mountains, and you can see the shadows cast by the low angle of the sun. And even if you don't take pictures, if you just watch the moon night after night, if you get the opportunity of no cloud, it can be fascinating just watching the shadows change over the mountains as the moon goes around the Earth. So that's one reason why you might want to think about buying a pair of binoculars or a small telescope, because you get wonderful views of our nearest neighbor. And if the telescope collects enough light and gives you enough magnification, you can see detail in some planets, for instance. Here, I hardly need to tell you what that is. Even if you didn't have the title in the top right there, you would all recognize what this is. So in a small amateur telescope, you can recognize Saturn, you can see the rings of Saturn, and it's a beautiful sight to behold. But the point I'm trying to make in this short talk is you don't need to go out and think, how much money do I have to spend on a telescope in order to photograph the night sky? One option, which not everybody is aware of, is you can take your camera and bolt it onto a little box, which is called a tracker, or a star tracker. And a star tracker is just a box with a motor in it, which will turn the camera at the same speed as the Earth. The Earth rotates once a day, which is why the stars appear to move once a day. If you can get your camera to do the same thing, then your camera follows the stars, and so you no longer get the stars trailing into the arcs that I was showing at the beginning of the talk. So here's an example of one star tracker. I didn't bring one along, but it's about yo-big, that sort of size, quite a few centimeters on each edge. You can perhaps judge roughly how big it is from looking at these various pictures, which I stole off the internet, of different people who've put their camera onto one of these trackers. The little tube on the right-hand side there is simply to make sure you've got it lined up with the Earth. The Earth rotates about an axis, and the star tracker needs to be set up parallel to that axis. But once you've done it, it simply turns the camera at 1 revolution a day and then will follow the sky. So your stars are no longer trailed, they're now pinpoints. You don't have to go out and buy a star tracker. You can build one yourself if you like, if you're a DIY enthusiast. For any of you that wants to give it a try, I've got instructions as to how you might want to build your own star tracker. I built one a few years ago. It looks rather odd, but it does the job. And the alternative is to go out and buy one. These commercial star trackers might be clockwork and they might be motorized. What? Yes?
It needs a motorized circuit. I have an actual circuit kit and I've actually made a piece game of it.
Have you? Okay. Yeah, let's have that at the end, shall we? So you don't need to know the detail, but a star tracker is just effectively a motor in a box. So in other words, there's a motor that drives a gear and this big wheel turns at 1 revolution per day. And of course there's some batteries inside it and there's a little bit of electronics just to make sure it turns at exactly the right speed. That's all a star tracker is, a motor in a box. So let me show you some pictures I've taken of the night sky with my camera. The camera I use for taking pictures in daylight. Nothing special about the camera. It's the same camera I would use for taking a picture of my cat or birds if I was interested in bird watching. Yes? Yeah? Okay, we can have questions later if you like. Okay, so here's a few images. One thing to bear in mind, if you do take a picture of the night sky, don't expect to get the same sort of picture that you see from the Hubble Space Telescope. You have to be realistic as in terms of what you are capable of doing, what your instrument, what your camera is capable of doing. Sometimes you might point your camera at the sky and think, well, that's a bit disappointing. Okay, the stars are pinpoints. That's one thing to bear in mind. They haven't moved because the tracker is moving the camera and following the stars. So the stars are pinpoints, but it's not very interesting. But the beauty of taking images with a digital camera, not using film, which some of you might remember, but these days when we're using digital cameras, we can put that image into our computer and we can tweak the brightness and we can tweak the contrast. And what's actually in that image, when you've tweaked it a little bit, you find there's far more there than you first thought. And if you play around with the colors, you can really bring the color out. So in fact, there's a big reddish pink nebula there, a big cloud of hydrogen. It's rather difficult to see in the first image. You can probably not even make it out, but the camera has captured it. You just do a little bit of playing in your favorite graphic software, whether it be Photoshop or something else. You do a little bit of playing and lo and behold, you get some wonderful images coming out. Here's some pictures I took not from Liverpool, but from a little way towards the West Midlands, where I was at a star party with some friends, and I've taken a picture of a star cluster here, and the stars come out with this beautiful luminosity, this blue color around the stars. Here's a huge galaxy. This is a galaxy close to our own, the Andromeda galaxy. It's a big spiral galaxy, and it has a couple of small companions as well. And in the top right, that's the result of a star blowing itself to pieces a few thousand years ago. And what you can see is a sort of almost a bubble, a circle if you like. These are the remnants of this star that blew itself to pieces about 5,000 years ago. So remember, these are not taken with a telescope. These are taken with a camera, and to stop the stars trailing, we put the camera on a star tracker. But apart from that, it's a normal camera that's used for daylight photography. Cameras these days are so good, you can often use them for night photography as well without any modifications. You just have to make sure you follow the stars. So star clusters, stars that have blown themselves to pieces, and other galaxies are all within the reach of a camera without using a telescope. Yes? Mm-hmm.
They are blown up planets.
Shall we have questions at the end and then we can come back to that? Yes? So this is the Milky Way. We live inside a star city called the Milky Way. It's our galaxy. If we were to look at it from some distance, it would look like 2 fried eggs back to back. In other words, a bit like a plate with a bulge in the middle. But we're inside that galaxy. But when we look at the galaxy edge on, we see this band of light. Or at least we do if we can get away from the street lights. We're back to the problem of if you were to walk outside here and look up, even if we didn't have clouds, it would be difficult to see the Milky Way because of the number of lights that are around. If you can get away from those lights, out towards the suburbs, or better still, well away from the cities, then you can see the Milky Way. And with a camera, in this case a camera and a wide-angle lens, this is a large chunk of sky I'm photographing here, then you can get the beautiful streaks of the Milky Way. You see it's not just a uniform band of light, it's bright in some places and dark in some places, and the more you look at this, the more you see detail. I took this particular picture with a wide-angle lens, and then I changed to a somewhat larger focal length, and then, if you like, zoomed in to the region shown by that red rectangle there. And again, you can see much more detail. Some bright areas where there's lots of stars, some dark areas where the starlight is being absorbed, some little blotches, which are hydrogen clouds where stars are being born, and star clusters. Far too many for me to point out in this short talk. This is called a nebula. It's a particular type of nebula. It has a rather confusing name because these things are called planetary nebula. They are actually nothing to do with planets, but they're only called planetary nebula simply because these nebula look a little bit like circles of light that you would expect if you were looking at Jupiter or Uranus or Neptune or something like that. In fact, what this is a star that's blown away its outer atmosphere. When our sun comes to the end of its life, in a few billion years' time, our sun is going to swell up and it's going to lose the outer parts of the star, and they're going to be lost into interstellar space. And we're just going to be left with a very small star right at the core. So this is actually what is going to happen to our sun in a few billion years. It's going to swell up, and the outer parts of the star are going to drift off into space. Not as dramatic as a star blowing itself to pieces in a supernova. It's a somewhat sort of more sedate version of the same thing, a slow swelling, and then part of the star will be lost. So this, if you like, is the outer atmosphere of the star, and that little dot right in the center, that's what's left of the star once the outer parts have been blown away. So that's a picture I took with a camera and a telephoto lens. Just for comparison, that's what the Hubble Space Telescope view of the same object is. So remember, this was taken with a camera that I used to take pictures of my cat with, and that is a few $1 billion worth of Hubble Space Telescope. Now, I admit that the Hubble is better. Okay, I would not disagree with that. The Hubble is a better image. Is it 1 billion times better or 1 million times better? Well, it is very nice to say, well, I can look at this picture on the web and see what Hubble can do, but it is very satisfying to say, I can't compete with that, but if I take a picture from my back garden, I wonder what I can get. That was actually taken from a campsite, not from my back garden, but you get the general idea. There are beautiful colors out there. It is difficult for us to see the colors. When we look into the sky, we see stars, and a lot of them just look like they are sort of white. That's about it. But actually, the stars are colored. Some are red, some are blue, and sometimes you can catch those colors using the camera. Because there isn't much light there, your eyes are not well suited to picking up those colors, but the colors are there, and the cameras can catch the colors. Sometimes you need to do a little bit of tweaking in the graphics software to bring those colors out, but they are definitely there. That is actually a red giant star, which is causing the yellowish glow in that area, and here we have light that's being reflected from a rather bluish nebula. There's actually a large cluster of stars there. It might look like a big fat star. It's actually lots of stars. It's hundreds of thousands of stars, all in a very tight cluster. I'm not going to dwell on this, partly from time and partly for the audience, but just to let you know that during lockdown I got bored and asked myself, if I'm not using a telescope, how far can I see? That's not necessarily a question you normally ask. You're interested in, I want to take a picture of this galaxy or that nebula. But I just wondered, as a lockdown challenge, what is the most distant object I can photograph without using a telescope? So I looked up in a certain database a particular galaxy that I knew was bright enough to be seen from a great distance. And I figured out where in the sky that was, and I pointed my camera in that direction. That is not it at the center. That happens to be a star which is not so far away from the object I was trying to photograph. I took my camera and a rather longish telephoto lens, stuck it on the white box, the star tracker, and the galaxy that I was trying to image is actually inside that square there. If we blow it up, it looks totally and utterly unimpressive. That's it there, a tiny little blob of light. If we blow it up further, we can't seem to see much. It's probably the least impressive picture that's on show this evening in terms of showing you what the sky looks like. But when we think about what produced that light, it is really astounding. The fact that without a telescope, we can actually pick up the light from a galaxy that is billions, literally billions of light years away. The light has been traveling to us because nothing can move through space faster than the speed of light. Because of the distance to this object, the light has taken billions of years to reach us. The light that produced that little blob there left the galaxy long, long, long before the Earth even existed. It had been traveling for billions of years even before the Earth was formed. And in fact, the light that produced that image has been traveling for most of the history of the universe. The universe was born a long, long time ago, and for most of that time, the light has been traveling to reach us. And it can be detected by a camera without using a telescope. I thought that was pretty amazing. How come this object is so bright it can be seen from such an enormous distance? Well, we think what's going on there, we can't be sure, but we think what's going on is there is an enormous black hole at the center of this particular galaxy. And matter, stars, other stuff that's falling into this black hole is getting so hot it's radiating huge amounts of energy. And that's why we can see it despite the fact that it is billions of light years away and the light has taken billions of years to reach us. Let me just say a few words before I finish about getting away from streetlights. If you ever get the chance, I can certainly recommend for those of you who might be interested in wildlife. I'm interested in wildlife, I'm interested in astronomy, and as you can probably tell, I quite like to do some photography as well. And I find that those three can overlap because with a good pair of binoculars, you can look at wildlife, whether it be birds or animals. With a good pair of binoculars, you can do some astronomy. And if you're interested in photography, you can photograph wildlife and you can photograph the sky. So those three interests all overlap each other. And in particular, they overlap if you want to go somewhere interesting, like for instance, go on safari in Africa. You can then look and photograph animals by day, and you can watch and photograph the stars by night. Sleep when you get home. Go on holiday, animals by day, stars by night, sleep later on somebody else's time. So that, as far as I'm concerned, is an absolutely ideal holiday. This is, roughly speaking, a way I'm trying to impress on you the fact that from England, from the UK, you might be able to see the Milky Way as a band of light across the sky. If you get away from street lights, that band of light becomes so bright it is truly impressive just to stand there and gawp at the Milky Way over your heads. If you then photograph it, remember your eyes are not well suited to picking out the color in the night sky, but if you photograph it, then you can start to see what colors exist as well. And this is a picture taken, again, a relatively wide-angle lens here, and again, a camera sitting on a tracker to make sure it follows the sky over a period of quite a few minutes to take a picture like this. In this particular case, that bright thing there that looks a little bit like a star is actually Jupiter, and on the left-hand side, again, what looks like a modestly bright star is actually the planet Saturn. So as well as picking up the swathe of the Milky Way, there's actually a red giant star over here, and there's also two planets in the same field of view. So I've taken just a little bit less than half an hour to try and convince you that if you're interested in taking pictures of the sky, you do not have to say, there's no point because I haven't got a telescope. That is definitely not the attitude to take. If you want to take pictures of the night sky, you can do it just by putting a camera on a tripod, or with a modest investment of either a little bit of DIY, build yourself a tracker, or if you've got deeper pockets, buy yourself a star tracker, you can put a camera on a tracker, and you can take glorious images like this, especially if you can get yourself away from some of the light pollution that exists out there. So I have copies of the slides of my talk if anybody would be interested. I can also talk to people about how you would buy yourself, how you would make yourself a star tracker, and I'd be happy to talk to anybody if anybody is interested in how do I go about thinking about buying either a telescope for my youngster or possibly a telescope for myself. Thank you all for listening.